NEET stands for National Eligibility Entrance Test. This is the abbreviation of NEET. It is National Eligibility Entrance Test. Prior to these NEET exams, we had different exams like JIPMER, CET in Karnataka, AIMS. They used to have a separate exams, but the government of India decided to have a common entrance test for the medical, and they proposed the National Eligibility Entrance Test called as NEET. And this NEET exam is for undergraduate students. Now, NEET application for 2023 is out. NEET application is out. And you need to fill it up by 6th of April. The last day is for filling and submitting the application is 6th of April, 2023. And the exam is expected to happen on, 7th of May, 2023. Now, this NEET exam as such will have 200 questions. The pattern is slightly changed from the previous pattern, 200 questions. Each subject will have 50 questions each. Physics 50 question, chemistry 50 question, zoology 50 questions, and botany you'll have 50 questions. Totally you'll have 200 questions. Now, each paper you will have part A and part B. So each subject you will have part A and part B. In part A, you will have 35 questions. You have to answer all the 35 questions. In part B, you will have 20 questions, not 20, 15 questions you'll have, sorry. You'll have 15 questions, out of which you will have to answer 10 questions. So that means they've introduced a choice in NEET exam this year. So in all the subjects, the part B, you will have 15 questions and you have to answer 10 questions. So this is the question paper pattern. And each question will carry 4 marks. So you are expected to answer in each subject 45 questions. That is 35 from part A and 10 from part B. So 45 questions into 4, it will be 180. So this is for physics, and similarly for chemistry, it will be 180. Zoology, it will be 180. And you'll have botany, again, 180. Totally, the exam will be conducted for 720 marks. And you will have negative marking here. You'll have negative marking. So the wrong answer, there will be a reduction of 1 mark. This is about the question paper pattern of each subject. And equal weightage will be having for first year and second year, 11th and 12th. First 11th and 12th, or first and second year PUC. So you need to concentrate. Now you have around 1 lakh medical seat, MBBS seat, Bachelor of Medicine and Bachelor of Surgery. You have around 20,000 seats, or 20 to 25,000 seats for dental, that is BDS. Around 50,000 seats, for BAMS, Ayurvedic medicine, homeopathic medicine, Unani medical medicine. So, and you have Siddha medicines. So all together, that's BSMS, So all these together will be around 50,000 seats. And we have Bachelor of Veterinary Science and Animal Husbandry, Bachelor of Veterinary Science and Animal Husbandry. You'll have few seats. Now, to get into admission for any of these courses, this BAMS, BHMS, BUMS, and BSMS are called as Ayush. It's related to Ayurvedic, homeopathy, Unani, and Siddha. To get into these medical colleges, you need to qualify your NEET exam. So with this information, we will start with our program to solve some of the previous question paper and some of the questions from the previous question papers and the type of NEET questions which can be asked. All right, so I'll erase this and we will start with some of the questions. So I clearly told you the paper is for 720 marks. Negative marking will be there. Choices will be there in part B. And this exam is expected to happen on 7th of May. And last day for filling up the application is 6th of April 2023. And I told you briefly also the number of seats available. There's around 99,000 medical seats last year. And recently there's a new medical colleges has come up. Around 600 new medical MBBS seats are being added up. So with that information, I told you it will be around 1 lakh medical seats. So there will be a large number of people competing for medical seats all over India. So prepare well. There's a possibility. They are considering only your NEET exams marks. So if you are eligible to take up the NEET exam, then the exam only will fetch you. The NEET exam marks only will fetch you a seat. So no 12 marks will be considered. Only for eligibility, maybe around 50%, 55% that eligibility, you need to have to take up this NEET exam. All right, some of the questions we will solve from the previous year question paper. It'll be from the first year as well as from the second year. Now at constant temperature and 1 atmospheric pressure, PCl5, phosphorus pentachloride, dissociates 20%. At what pressure PCl5 dissociates to 150, dissociates to 50%. So 20% dissociates at 1 atmospheric pressure. So at what pressure it will dissociate? 50%. Now we know that PCl5 will dissociate to form PCl3 and Cl2. Now the initial concentration of PCl5 is 1 and PCl3 is 0 and chlorine is also 0. Now, if we say from 1 mole, alpha mole dissociates, alpha moles of Cl3 is formed, alpha moles of PCl3 is formed, and alpha moles of Cl2 is formed. So therefore, total number of moles will be equal to 1 minus alpha plus alpha plus alpha. That will be equal to 1 plus alpha. Now, for this particular equation, since it is in gaseous state, Kp is written as, Kp is calculated by the formula alpha square P, alpha square divided by, alpha square P divided by 1 minus alpha, alpha square, 1 minus alpha square. Now, to be more clear, Kp is written as alpha square divided by 1 minus alpha into P divided by 1 plus alpha to the power 1. So we can write that as 1 minus alpha into 1 plus alpha can be written as 1 minus alpha square. So they've given 20% dissociated. 20% dissociated means 0.2. So we can write Kp is equal to 0.2 the whole square divided by 1 minus 0.2 the whole square. That will be equal to, they're asking 50% dissociated. The pressure for 20% dissociated, they've given 1 atmosphere. So I write it as 1. I equate it with 50%. So for 50% dissociation, it is 0.2 0.5. 50% dissociation means 50 divided by 100, it's 0.5. 20% dissociation means 20 divided by 100, it's 0.2. So 0.5 into 0.5 the whole square into P divided by 1 minus 0.5 the whole square. So if we equate and simplify for P, the answer what we will get is 1 by 8. So therefore, the answer for this question is 1 by 8 atmosphere. First, at constant temperature, temperature is constant, and 1 atmospheric pressure. At 1 atmosphere, PCl5 dissociates 20%. If it has to dissociate 50%, the pressure has to be decreased to 1 by 8 atmospheres. So therefore, the dissociation will be 50%. The second question, 4 moles of ammonia plus 5 moles of oxygen gives you 6 moles of water and 4 moles of nitric oxide. This is the preparation of nitric acid by Oswald's process. Oswald's process. If you remember, the first step in the Oswald process is this. Taking 1 mole of ammonia and 1 mole of oxygen. Oxygen is completely reacted. Ammonia is completely reacted. Both 1 and 2 are correct. None of the above. Now, the stoichiometric coefficient of ammonia is 4, and the stoichiometric coefficient of ammonia is 5. So the ratio is 1 divided by 4 will be 0.25, and 1 divided by moles. If we take 1 mole, they will give 1 mole of ammonia, 1 mole of oxygen. 1 divided by 5, it is 0.25. This is for ammonia, and this is for oxygen. Here this is 0.2, sorry, this is 0.2. Here it is 0.25. It's 0.2. Now we can understand that the number of moles of the concentration of oxygen is lesser compared to ammonia. Limiting reagent means in a reaction which is consumed completely, or a reaction which will limit the reaction, a reactant which will limit the reaction to take place is called as limiting reagent. Limiting reagent. So this is a first PUC topic. Some concepts in basic chemistry. That's the topic, right? So limiting reagent. Since the concentration of oxygen is less, oxygen will be consumed completely. Since oxygen will become consumed completely, oxygen is called as the limiting reagent. So therefore, the answer for this question is option 1. Oxygen is completely reactive. Oxygen is the limiting reagent. The next question. Equivalent weight of KCl, MgCl2, and 6H2O. This KCl dot MgCl2 dot 6H2O, it is an example for double salt. A double salt is obtained by combination of equimolar simple salt. If you take 1 molar of KCl and 1 molar of magnesium chloride, mix them and heat it to dryness, the solid what we get is called as a double salt. In this case, let us find the oxidation number of all the elements. Potassium is +1, chlorine is -1. Magnesium is +2, chlorine is -1 into 2, so it will be -2. So total positive charge is +3, and total negative charge, you can see total negative charge is -3. +1 into +2 is +3, -1 into -2 is -3. So therefore, the equivalent mass of the salt or equivalent weight of the salt is molecular weight divided by 3. That is 3 electrons lost and 3 electrons gained. So +3 means 3 electrons lost, -3 means 3 electrons gained. So equivalent weight of this salt is given by molecular mass divided by the number of electrons lost or gained. So here it is 3. So it is m by 3. Therefore, the answer for this question is option C. The next question. The pKb of dimethylamine and pKa of acetic acid is 3.27 and 4.77 respectively at a temperature K Kelvin. Temperature T Kelvin. The correct option of the pH of dimethyl ammonium acetate is pKb corresponds to base, that is dimethyl ammonium, and pKa corresponds to an acid, acetic acid. They have given the value is 4.77 at a particular temperature, T Kelvin. The correct option of pH of dimethyl ammonium acetate. So since it is a base and it's an acid, a salt is formed, and that salt is called as dimethyl ammonium acetate. For a salt, we can find pH by the formula 7 plus half of pKa plus, not plus, minus of half of pKb. That is equal to 7 plus half into 4.77 minus half into 3.27. pKb is 3.27. So on simplification, the answer we will get is 7.75. So therefore, the answer is option 3. Option 3. Next question. Are you following? This formula we have not learned in our syllabus, but you should know how to find Anderson's equation we have learned. For a buffer solution, how can we find pH? pH is equal to pKa plus log of salt concentration by acid concentration. All this we have learned, pH is equal to. And for a buffer solution, basic buffer, pOH is equal to pKb plus log of salt concentration by base concentration. This is Anderson's equation. So these kind of problems we have not worked in a regular PUC class, but you should try to find out how to find the pH of a salt formed by the reaction between base and an acid. The next one we have is the wave number of first line in Balmer series of hydrogen. Wave number of first line in Balmer series of hydrogen is 15,200 centimeter. What is the wave number of first line of Balmer series in lithium ion? Now we know that hydrogen spectrum, we have different series. And if I write like this, this is principal quantum number, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, and n is equal to 6. In case of Balmer series, any electron from higher level, it can come to N2. From highest state comes to N2. So therefore, in case of Balmer series, N1 is always 2, and N2 can be 3, 4, or it can go like this. This is the N1 and N2 in case of Balmer series. We have different series of lines. Now the question is, the wave number of first line of Balmer series is given 15,200 centimeter inverse. Energy can be expressed in terms of centimeter inverse also. What is the wave number of first line of Balmer series in lithium ion? Li2 plus is different, hydrogen atom is different. So we know Rydberg's equation 1 by lambda is equal to R into N square into 1 by N1 square minus N2 square. This is Rydberg's equation. So for hydrogen, we can write, for hydrogen atom, we can write 1 by lambda of hydrogen is equal to R into 1 square. Atomic number, it's not an atomic number, is Z square. Hydrogen atom atomic number is 1 into 1 by N1 is always 2 at 2 square minus N2. Since they're talking about first line is also called as H alpha line. First line is also called as H alpha line. The second line in the Balmer series, I will explain. Second line in the Balmer series will be called as H beta. And third line in the Balmer series is also called as H gamma. Now, what is this first line? Now, this is first line, H alpha line. If N2 is 3 and N1 is 2, it's called as H alpha. This is called as H beta. N2 is 4 and N1 is 2. I told you N1 for Balmer series, always it is 2. So N2 can vary. So 3, 4. If N2 is 4, then it is called as H beta line. Now, since they're talking about H alpha line, N1 is 3 square. This is for hydrogen. Now, I'll divide this by 1 by lambda of lithium ion, Li3 plus. That is equal to R. Atomic number of lithium is 3. 3 square into 1 by 2 square minus 1 by 3 square. So when you divide these, and we know that the value for the wave number is nu bar, that is 1 by lambda. They have given for hydrogen as 15,200 centimeter inverse. That is equal to R into this. If you can simplify, you will get 1 by 9. No, maybe R into 1 square into 1 by 2 square minus 1 by 3 square and divided by this we are supposed to find. So 1 by lambda of Li2 plus will be equal to R into 3 square into 1 by 2 square minus 1 by 3 square. I think this factors will get cancelled. This value, whatever's in the brackets, will get cancelled. It's the same. So we can write this as 15,200 divided by 1 by lambda for lithium ion will be equal to, and this R also will get cancelled. So it will be 1 square is 1, 3 square is 9. So therefore, if we simplify this for 1 by lambda Li2 plus, the answer what we get is 136840 per meter. 136840 per meter. This is the value. See, mathematics, kindly practice it. Practice it. Let's cross multiply 15200 into 9. So that will give you this value in meter. See, options are given in meters here. And only they've given this in centimeters inverse, but this is meter inverse. Since they've given in meter inverse, we have to multiply this by 100 also. So the answer will be like this: 9 into 15,200 into 100. So you'll get 136840. Therefore, the answer is option. The next question. N2O4, dinitrogen tetroxide, decomposes to give dinitrogen tetroxide, decomposes to give nitrogen dioxide on heating. Color of the solution deepens. Then delta H for the reaction will be. Delta H stands for enthalpy. And color on heating deepens. They say color of the reaction deepens. Delta H of the reaction will be. Just give me one moment in time. This N2O4, right? I say everything here. Dinitrogen tetroxide undergoes reaction or decomposes to give dinitrogen nitrogen dioxide. Delta H for this reaction. They're asking whether it's negative, positive, 0, or 95. Negative means it is exothermic reaction. Positive means endothermic reaction. 0 means the reaction is in equilibrium. As per the reaction, it's in equilibrium, unidentified. This reaction, delta H, is positive, meaning it is an endothermic reaction. So without heating, this dinitrogen tetroxide will not give you nitrogen dioxide. This nitrogen dioxide is brown in color. This dinitrogen tetroxide is colorless. So it's mentioned here, colorless and colored. So this reaction is an endothermic reaction. Endothermic reaction means delta H is represented as positive. It absorbs heat, otherwise the reaction will not take place. Now the coordination number of cation and anion in fluorite and antifluorite are respectively. Now, this coordination number is not from the chapter coordination compounds. This coordination number, what we're talking, is from the chapter solids. What is coordination number? Number of ions surrounding the ions under reference is called as coordination. Now, for an example, if I write a crystal like this, if I write a cube like this, and if we say at the center we have cesium, this is cesium, Cs, and all this we have chlorine. At the 8 corners of the cube, we have chlorine. This is a chlorine. So this is chlorine. This is also chlorine. This is also chlorine. Maybe in order to understand that, we can have a different color for cesium. If I represent this as cesium, and all these are chlorine. Now, if you can observe clearly, each cesium atom is surrounded by 8 chlorine atoms. So therefore, the coordination number of cesium is 8. Likewise, if you take a crystal, the coordination number of chlorine and cesium is also 8. That means each chlorine ion will be surrounded by 8 cesium atoms. So we are not able to show the structure of the extended structure of chlorine. Only for cesium we have shown. Now, the similar manner, they are asking the coordination number of cation and anion in calcium fluoride and antifluoride. In case of calcium fluoride. So calcium is a cation and fluoride is an anion. So for calcium, the coordination number is 8, and fluoride, the coordination number is 4. That means each calcium will be surrounded by 8 fluoride ions, and each fluoride ion will be surrounded by 4 calcium ions. So now if you take sodium and oxygen, in antifluoride we have sodium and oxygen. The coordination number of sodium is 4 and oxygen is also 4. Each sodium will be surrounded by 4 O2 minus, and each O2 minus will be surrounded by 4 Na plus. Therefore, the answer for this question is option. No, it's wrongly typed here. It is 8:3. It is 8:3. It is a printing mistake maybe. So this is 8:3, not 3, and not 6. The answer for this question is option. No. Sorry. No, this is the right answer. Yeah, 8:3. 8:4 you should have. Somewhere something has gone wrong. The answer is 8:4 and 4:4. This is the right answer. I think none of the options are showing this answer. Right, so this is the answer, 8:4 and 4:4. Kindly make a correction if at all possible. The next one is, choose the correct option for graphical representation of Boyle's law, which shows a graph of pressure versus volume and of a gas at different temperature. We all know that Boyle's law, at constant temperature, pressure is inversely proportional to volume. This is Boyle's law. At constant temperature, pressure is inversely proportional to volume. Now, they are plotted a graph here. Choose the correct answer for the graphical representation of Boyle's law, which shows the graph of pressure versus volume at different temperature. So these two graphs look similar, pressure versus volume, but you can see here, temperature at 600 Kelvin, pressure is high, volume decreases partially. Lower temperature, pressure is high and volume decreases. So the answer for this question is option 4. So that is T1 is less than T2 less than T3. The answer is 4. We can mark this as T1, T2, and T3. Lower temperature, T1, T2, and T3. Hence, the answer for this question is option 4. Oh, well, sorry. The next question. The extent of when temperature is increased, when temperature is increased, extent of adsorption increases in physisorption, extent of adsorption decreases in physisorption, no effect on adsorption. Extent of adsorption first decreases, then increases in physisorption. So whatever adsorption we are talking about, that is whether it is physical adsorption or chemical adsorption, it is an exothermic reaction. Any adsorption is an exothermic reaction. So delta H is negative. In the regular class, we would have learned the difference between physical adsorption. Physical adsorption is also called as physisorption. Chemical adsorption will be called as chemisorption. Since both physical adsorption, chemical adsorption is exothermic, now already during adsorption, energy is given out. So further, when you increase, the rate of adsorption will decrease. That is, as temperature increases, adsorption decreases. It is because any adsorption is an exothermic reaction. Hence, the answer for this question is option. The next question. T 100% for a first order reaction is 0.693 by K, A naught by 2K, 1 by A naught into K alpha. Now, first order reaction, see, try to know what is order, molecularity, and the formula to calculate the rate constant of different order reaction, all that. So first order reaction never goes to completion. Never goes to completion. That means no 100% reactant will react to give you 100% product. That is what it says. A first order reaction never undergoes for completion. So therefore, the answer for this question is infinity. Time required for completion of the first order reaction is infinite. Why? Because it never goes for completion, never finishes. Therefore, it is infinite. Wait. Where is that? Yeah. The next question. In Van der Waals equation, which will have highest value of A? Methane, helium, ammonia, and hydrogen. So for this, A is a constant. We know that PV is equal to nRT, ideal gas equation. Van der Waals equation, we know that P plus A by N square into V minus NB. I think the sum change, NB is equal to nRT. This is Van der Waals equation for N moles. Now, A and B are constant. A and B are constant. A corresponds to intermolecular force. A is directly proportional to intermolecular force of attraction. Intermolecular force of attraction. So in this, ammonia will have large amount of intermolecular force of attraction because of hydrogen bonding. Hydrogen bonding. Therefore, the value of A will be highest for ammonia. So intermolecular hydrogen bonding, that is hydrogen bonding between two molecules, will be called as intermolecular hydrogen bonding. So hydrogen bonding intermolecular will be maximum for ammonia. Hence, ammonia will have highest A value. This we will reduce the font size. Now, given below are two statements. One is labeled as assertion A, and the other is labeled as the reason. A, in a particular point defect, ionic solids is electrically neutral, even if few of its cations are missing from its signature. Reason, in an ionic solid, Fresnel defect arises due to dislocation of cation from lattice sites to interstitial sites, maintaining all over electrical neutrality. In the light of the above statement, choose the most appropriate answer from the options given below. Both A and B are correct, but R is not correct explanation of A. R is, in the sense, reason. R is not the correct explanation. A is correct, but R is not correct. See the question, the A assertion is in a particular point defect, ionic solid is electrically neutral, even if few of the ions are missing, they say. But in Fresnel defect, it is dislocation from its original site to interstitial site. Here they're talking about missing, here it is dislocation. Therefore, the answer is correct. A and B both are correct, but R value, R, that is reason, is not right. So R is not the correct explanation for A. So therefore, the answer for this question is option 1. The main products formed, product of the following reaction will be, what is the following reaction? So they have given a benzene ring here. Here we have CH2O, CH2, CH3, and you have O and CH3. Now, if it's allowed to react with excess hydrogen iodide, excess, they have given in the question excess hydrogen iodide. So what happens is the bond between oxygen and hydrogen breaks. Oxygen-carbon breaks. Hydrogen reacts with oxygen and iodine reacts with carbon. So therefore, the product, one of the product, what we get is CH3, CH2, that is it. But here also you have oxygen and carbon bond. Therefore, the bond between carbon and oxygen breaks. Iodine attacks this carbon and hydrogen attacks this. Therefore, we get a benzene ring, CH2I and OH, plus of this one, CH3, CH2OH. And third product, what we get is CH3I. The answer for this question is option 1. This is the answer. See, the major product is this. So it is option 1. The next question. Now, try to identify phenol reacts with sodium hydroxide, carbon dioxide, and it's acidified later. It forms a compound A. This compound A, which is formed, reacts with NaOH and calcium oxide B, and this B reacts with bromine and water. Bromine, you get product C. They're asking, what is the question they're asking? They're asking the final product. Okay. Now, the first step, if you can observe, sodium hydroxide and carbon dioxide, phenol. This reaction is Colway's reaction. Colway's reaction. Colway's reaction. So we'll get the A, what we get is salicylic acid. This is salicylic acid, COOH. Since we have sodium hydroxide, it will react with sodium hydroxide to form sodium salicylate, COONA. And this is A. No, this is A. This is A. This, when allowed to react with soda lime is used to decarboxylation. So this undergoes decarboxylation again to form phenol. Again, the compound B formed this phenol. This is B. Sodium salicylate, and again the product formed B is phenol itself. This, when allowed to react with bromine water, it is ortho-para-directing group. OH is an electron donating group. It is ortho-para-directing group. Therefore, we get 2,4,6 tribromophenol, a white precipitate of 2,4,6 tribromophenol. Therefore, the answer for this question is option 4. So long reactions. First is Colway's reaction. Next, you get sodium salt of carboxylic acid, then sodium salicylate, and that's decarboxylated. Again, we get phenol. And this phenol, when brominate, you get 2,4,6 tribromophenol. Sorry. The next question. Hey, What is that? Now, this question I'm not clear with. This question I'm not clear with. And the next one we will see. Substitution takes place at first carbon, or it is OCH2. So they say the reaction to take place at the fourth position. But anyways, I'm not clear with this question. You can search it. Which of the following is a non-reducing sugar? Which of the following is a non-reducing sugar? It is option 3. That is B and C. B and C. This is a non-reducing sugar. Well, there's a huge rain coming up. I may get the internet problem. Let's see. So the answer B and C, these two are non-reducing sugar. You can identify this as fructose. Oh, just give me some time. No power. The next question. The major product of the given reaction. The major product of the given reaction, that is, it's not an aromatic compound because it's not a benzene ring. And NaBH4 is a reducing agent. Sodium boron hydride, NaBH4, is a reducing agent, a strong reducing agent. So the answer for this question is option 1. So this reducing agent, sodium boron hydride, NaBH4, will not reduce COH. So reduction will happen only at the aldehyde group here. So therefore, the product what we get, reduction is addition of hydrogen. So the aldehyde will be reduced to alcohol. So and this remains COH. This is not a benzene ring. I made it a mistake again. So this will not be there. So sodium hydrogen bromide, you have to remember, even though it's a strong reducing agent, it is not strong as lithium aluminum hydride. Therefore, it will not reduce the COH group. It will reduce the aldehyde group to alcohol group. So therefore, the answer for this is option 1. The next one. Which of the following reacts with tolerance reagent? Aldehyde, that is phenyl group, and aldehyde, that's benzaldehyde. They've given so many options. C is this, D is acetic acid, formic acid, fructose, and mannose. The answer for this question is, which of the following reacts with tolerance reagent? A reacts, aldehydes reacts, acid gets reduced to acid, aldehyde, and it also reacts. F, G, and D, all this reacts, excepting for this, all the other reacts. Hence, the answer for this question is option 2. Match list 1 with list 2. Cationic detergent. Cationic detergent. Sodium lauryl sulfate. Sulfate is negative. So that means this should be positive. It is true. Anionic detergent. Cetyl trimethyl bromide. Ammonium bromide. Bromide is negative. Ammonium is positive. Right. So this is not soap, sodium stearate. So this is correct. Non-ionic detergent. Product is formed after the reaction between stearic and ethylene. This is not it. It becomes a polymer. So it becomes a polymer. It's not an non-ionic detergent. So the answer for this question, I feel somewhere something wrong. Both are cationic detergents. And this is a soap, no doubt about it. And I mentioned this to be anionic, and the answer what has been given is also this. So this is, I feel this is wrong. The options are wrong, the list too. So the next question. Proton acceptability, basic nature of aniline would be less than that of ammonia. In case of an ammonia, we have a lone pair of electron. Lone pair of electron donors are called as Lewis pairs. Likewise, in case of aniline, we have nitrogen and NH2 like this. Here also we have lone pair of electron. But what happens is this lone pair of electron moves towards the benzene and it undergoes a resonance. Therefore, the availability of lone pair of electron on nitrogen will decrease. Therefore, the basicity of ammonia is greater than aniline. The lone pair of nitrogen aniline is involved in resonance. The first statement is proton acceptability, basic nature of aniline would be less than that of ammonia. Statement lone pair of nitrogen in aniline involved is in resonance. So therefore, the answer for the question is option 1. Both statement 1 and statement 2 are correct. So it is 1. The next question. Where is that? So this is an organic compound. So you can name this, and this is allowed to react with sodium methoxide. The major product in this reaction they're asking. Halogen, which is present at para position with NO2. So this is a predominating substituent. So this is para position. This is a halogen, which is at para position. Will be replaced due to the formation of stable carb anion intermediate. This will be replaced due to the formation of stable carb anion. So that means carb anion means carbon having negative charge. Therefore, the product what we get is, we get a benzene ring, we get NO2, you will have Cl here. This Na plus and this Cl will be eliminated as NaCl. In place of this Cl, what goes CH3O. So you can write it like this. Therefore, the answer for this question is option 2. So some of the other questions we will learn in the next class. From other questions we'll learn in the next class. Ma'am,